Okay, for 6.2 we will be studying inverse functions and relations. The secret key for success today is going to be to switch the x and y. So to start off with a super easy example here, actually I'm going to highlight this. Switch the x and y. I cannot express to you how important that is. Switch the x and y. If you have a point, and points are always given to us in the form x, y, then just switch it. So -8, -3, switch it. -3, -8. Seriously, that easy. Okay, do the next points. -8, -6. This is going to become -6, -8. And last but not least, -3, -6 is going to become -6, -3. And we can go ahead and plot these. -8, 1, 2, 3, 4, 5, 6, 7, 8, and -3. And it's going to become -3, -8, 1, 2, 3, 4, 5, 6, 7, 8. Oops, kind of touched it there. Okay. -8, -6 is going to become -6, -8. And then let's see, -3, -6. 1, 2, 3, 4, 5, 6. This creates this triangle. What do I need? -6, -3. Ooh. What you might notice is that this is a reflection across the identity line. The identity line is y equals x, and it's the line that goes exactly diagonal across your graph. So if I could pick this graph up across, or pick this graph up off the page and fold it along this dashed line, the triangle would land exactly on top of its mirror image there. So that's what this is. It's a reflection across that line. So what's going to be difficult today is finding the inverse of an actual function. So here's kind of some vocabulary, math vocabulary. If you have f of x, that's just a regular boring function, right? If you have found the inverse, that's where you're going to use this little thing like that, where it has that -1. Highlight that for you. So find the inverse of each function. We're not going to worry about the graphing part. You're going to have some steps here. Step 1, I want you to rewrite using y. Because when I do that, that is going to allow me to see that I have an x and y, which will let me use the secret to success for today, which is to switch x and y. Now when you do that, you are only switching the x and y. Don't switch any numbers, exponents, or anything. You're only just switching the x and y. From here, I want you to solve for y. So in this specific instance, I think I'll multiply both sides by x. Add 3 to both sides. So this is going to get me in a good spot. What color? There we go. With the 5x plus 3 equaling y. So then from there, with step 4, the last thing you're going to do is write your answer in function form. And, or function notation is probably what I should have wrote instead. What I'm going to do is, instead of writing y, I'm going to put this back in the function notation. But I'm going to remember that function notation is going to use this up here. So my final answer is going to be the inverse function of x equals 5x plus 3. And that is your final answer. All right, I want you to see something else from this chapter, but I'm not going to do all the work for it because it does take quite a bit, and I don't think you're going to see this in your homework, except for like maybe one problem. Basically, here's a rule you need to know. If a pair of functions are inverse functions, you can verify that if their compositions equal equal x. And that's what this rule up here is saying. If f of g of x and g of f of x both just equal x, then they are inverses. So look at 3b. I've already done all the work here. When I plugged one inside the other and did all the work down, they both just equaled x. Since they both equaled x, they are inverses, yes. But let's check out 3a. When I did that one, I started just by doing f of g of x, and when I simplified, I ended up with this x plus 9. That's not a good thing. I can't have that plus 9. It has to be just x. So this means that they are not inverses, and that's my answer there.